Advanced Algebra 1 video for topic 3, exponential growth and decay. So, exponential growth equation is given as f of x equals a, and a is the initial amount, the amount invested, whatever you want to call it there. Then 1 plus r is the rate in which the investment is growing, the x, and the x is the time. Okay? When we get into pre-calculus, we don't use these variables, and even maybe sooner than that. So if I have a tendency to write a of t equals a sub 0 times 1 plus r to the t, it's the same formula, and it's just because I've written it this way for 30 years, and I've written it this way for 2 years. So if I revert back to my old ways, it's the same thing. And a of t is the amount of money with respect to time. A sub 0 is the initial amount. R is the rate at which it's invested, 6%, 8%, or the rate that it's growing, and t is time. Okay, so the population of Hillville grows at an annual rate of 15%. What will be the estimated population in 5 years? So basically, we plug that into our f of x equals a times quantity 1 plus r to the x. So and I must not have typed this in, but in the original problem, the original amount is 5,000. F of x 5,000 times 1 plus 0.15, I don't put the percent, decimal, and what will be the estimated population in 5 years. Then we go to our calculator, and we can punch that in as 5,000 parentheses 1 plus 0.15, then use the up caret 5, and we get, and we're going to round it. We're going to round it to the nearest person. We can't have a part of a person, so we're going to say that this is approximately 10,000. 10,000. Then the population is 5,000 with an annual increase of 1,000. So in other words, we're starting out at 5,000, and then every year increases by 1,000. So year 2, year 3. So if this were the case, what they're asking is this, could we use exponential growth to determine this? And the answer is no. And you're not sorry. This would be a linear model, because this is going up by 1, going up by 1,000 each time. In fact, this would be our y-intercept, and our slope would be 1,000. So we could write it, y equals 1,000x plus 5,000. So then at the end of year 1, 1,000 times 1 is 1,000 plus 5,000 is 6,000. And so what we have up here is an exponential model. And that's really what we're working with. But they do want us to be able to identify between the two. And what we have down here is a linear model. In fact, remember back to it, we could title this arithmetic sequence, where the explicit formula is a of n equals a sub 1 plus times the quantity n minus 1. And if I plug in my information, come up with that same exponential decay. Things we study with exponential growth is exponential decay. Not every investment grows, not every purchase grows, etc. I buy a car and I take it off the lot, its value decreases. I buy a computer, over time its value decreases because there are new and better models coming out. So exponential decay, again, f of x equals a, that's our initial amount, times 1 minus the r, rate of decay, to the x power. And again, if I revert back to a of t equals a sub 0 times 1 minus r to the t, it's the exact same thing. The amount over time equals the initial amount times 1 minus the rate of decay to the t to the time. How long? So a video is labeled a fan favorite. It receives at least 1,000 views per day. Amelia posts a video that gets 8,192 views on the first day. So there's my a sub 0 or my a. The number of views decreases by 25% each day after that. And how many days total will the video stop being a fan favorite? So what we want to plug in, we want this to equal 1,000. We want it to be 1,000 views per day. So f of x equals a times r minus r to the x. We want this to equal 1,000. And we're starting with 8,192. This is 1 minus 0.25, and then to the x power. Okay. What we want to do to solve this is we want to divide by both sides by the 8192. And in doing that, I get 0.1207. Then 1 minus 0.25 is 0.75 to the x. And then now it becomes a guessing game. Okay, I grab my calculator, and I'm going to take 0.75 to the 5th power. And what I'm trying to get is close to the 0.122. So 0.75 not sure what happened there. Not sure if I need to start over or what. But anyway, we want it to equal 1,000. How many? This is the initial amount, and it's decreasing at this rate. So what I want to do is just plug in numbers for x until I get approximately 0.12207. And I plugged in 5 for x. I took 0.75 to the 5th power. I got 0.237. So 0.75 to the 6th power. I got 0.177. We're getting closer. I'm going to take 0.75 to the 7th power. I got 0.133. 0.75 to the 8th power is too small. So it's somewhere between 7 and 8. So let's try 0.75 to the 7.5. And I get 0.1 is too small. So 0.75 to the 7.1, 129, 0.75 to the 7.2, 0.126, 0.75 to the 7.3, 0.1224, I think that's pretty good. So we're going to say that x is approximately 7.3. So in how many days will it stop being a fan favorite? In 7.3 days, approximately. Okay. All right. This is out of the book, so I found a picture. This little creature is called this. I don't know the pronunciation of that, but there it is. I would say pica in a region is decreasing. The population is decreasing by 8% per year. The initial population is 144. And how does the decrease in pica population for years 1 to 5 compare to the population for years 6 to 10? So what we want is we want to write our exponential decay function, a times 1 minus r to the x. So the r is 8%. The initial population is 144. And again, we want to find what we have going on here. I'm going to simplify that 144 times 0.92 to the x. Okay. And so basically we want to compare from year 1 to year 5 with year 6 to year 10. And what they're actually talking about here is the average rate of change. And whenever we see, average rate of change, we know that we're talking about slope. Okay. So to find the average rate of change from year 1 to year 5, I'm going to find f of 1, which means I'm going to plug 1 into this equation for x. Okay. So f of 1 is 144 times 0.92 to the first power, plugging in 1 for x. And I get 132.48. In your book, they round this to the nearest whole number, so they're going to call it 132. And then I'm going to find f of 5. And so I'm going to do the same thing, 144 times 0.92 to the fifth power. And I get 94.90 blah, blah, blah. Your book is going to call that 95. Okay? So the slope is 95 minus 132 over 5 minus 1. And I get negative 37 over 4, or negative 9.25. Okay? Now for year 6 to 10, I'm going to find f of 6. Again, 144 times 0.92 to the sixth power is 87. And I'm going to find f of 10. So again, 144 times 0.92 to the 10th power, and I get 63. So the slope is 63 minus 87 over 10 minus 6, or negative 24 over 4, which is negative 6. So what this tells me is that the population is decreasing at a faster rate from years 1 to 5 than it is from years 6 to 10. Okay, because here it's decreasing at a rate of 9 per year, and here it's decreasing at a rate of 6 per year. Okay, so that decrease is slowing down. So I don't know if that has to do with environmental actions that have taken place to try to decrease that rate of change. You know, it could be a number of things that it could apply to. Okay. And then both of these examples that I've done are what's called simple interest. Okay. It's 6% per year or 25% per year, or you know, something of that nature, but it's simple interest. Okay. And the simple interest is interest paid only on the principal, never on what it amounts to. Compound interest is where it's growing at a certain rate, and then I multiply that by the percent that it's growing, and then I take the new amount and multiply it by the percent that it's growing, and then I take the new amount, where simple interest is always taken, the percentage of growth or decay or whatever is always taken on the percent that of the initial investment. Okay, so compound interest is paid both on the principal and the interest from the investment. Okay, compound interest is what we want. That's better than simple interest. In our compound interest formula, they change up the variables on us. I'm not sure what the motive is in the book about that, but they change up the variables and they say that A, and that's the amount that I'm going to get, okay, from my investment, equals P, that's the principal investment. P is the initial amount. How much am I investing? Times the quantity 1 plus R over N to the NT. And again, what I'm used to is A of T equals A sub 0 times 1 plus R over K to the TK. Okay. So if I revert back to that, I apologize, but again, that's been 30 years and it's been 2 years. So, but I will try to keep the variables the same. And this means the same thing. It's the amount of interest I'm going to get. Here's my initial investment. R is the rate of investment. K is how it's compounded. In here, N is how it's compounded. Compounded annually is 1. That's simple interest. Compounded monthly, I would use 12 for N. Compounded quarterly, I would use 4 for N. Okay, so Kimberly's family invested in a certificate of deposit, a CD, for her when she was born. The amount deposited was $3,000 at 8% annual interest compounded quarterly. That means that N is going to be 4. What is the value of the CD at the end of 5 years? So A equals the principal amount, which was $3,000. 1 plus the rate is 0.08 compounded quarterly over 4. 4 times, we want to know how much it is at the end of 5 years. Okay, so here's your P, your principal investment. Here's the 1 plus R is 8% over N. N is compounded quarterly, so N is 4 to the N times T. So this is 4 times 5 because we're compounded quarterly for 5 years. Okay, and then we just go to our calculator and we figure that out. Take 3,000 times 1 plus 0.08 divided by 4, and we raise that to the 20th to 20, and we get 4,000, approximately 4,457 and 84 cents. And because we're talking about money, I took it out to the hundredths place. You need to read carefully in the homework what they want you to round it to, especially, specifically on the online homework, because they change it up. They'll say round to the nearest integer, which means I would have rounded this to 8 and stopped at the end of that amount. They may say round to the nearest hundredth because it's money, so you stop here. It's gonna be something different for each one, so make sure you read and answer accordingly. Okay. So in 5 years, it's grown approximately $1,500. Okay. Will the value of Kimberly's CD be greater after 15 years if it is compounded annually rather than quarterly? And again, compounded annually is the same as simple interest, because n is 1, and if n is 1, then if n is 1, then we're back to our simple interest formula. But I'll show you how that is. So again, $3,000, 1 plus 0.08 compounded annually, so n is 1, to the 1 times 15. Okay. And so we get 3,000 times 1 plus 0.08 divided by 1 to the 15th power. Uh-oh, says I made a mistake. Problem. Hold on. And I get roughly $9,516.51. Okay. If I take that and compound it quarterly, 0.08 over 4 to the 4 times 15, okay, then I take 3,000 times 1 plus 0.08 divided by 4 to the 60th power, and I get approximately $9,843.09. So which investment is better? Compounded quarterly, right? Compounded quarterly, I'm going to make more money than if I compounded annually. Okay. The last one. Mitch is, well, actually I'm gonna quit there. I just looked at the time on the video and we are kind of long already, so may need to do that example in class.